business that was once an engine manufacturer, now we're a parts manufacturer. 10,000 parts in an engine. And driving from that new metaphor, that new way of thinking about the business, Pratt & Whitney is able to attack the fragmentation. 50 business units that now become 7 product centers. And it's just not an attack on the structural fragmentation, but it's the way work is done. A focus on a single part, what we call part is manufactured, with an objective to reduce time dramatically, but also to reduce inventory levels dramatically, characteristics of real region. But there's one other characteristic here, and that is, in order to do this new work, this at times more complex work, but more interesting work, we have to retrain and re-educate the workforce.
In the surreal world of this 21st century factory, workers etch elaborate microscopic patterns on circles of silicon. The first step in the creation of integrated circuits, commonly known as chips, those magical miniature devices that power virtually every electronic instrument on the planet. This is Texas Instruments, an enormous conglomerate, making everything from guided missiles to pocket calculators. 60% of its business is here, in its multi-billion-dollar semiconductor division. But by 1990, that division was on a steady downward slide that threatened to drag the rest of Texas Instruments with it. The plan to save it came from a wild leap of imagination.
People that have been here in 1980 remembered what it was like being a winner. We were viewed as the best in the industry. People looked up to us. We were bringing new technology to the market. We were viewed as the innovator of integrated circuit. By the early 90s, people couldn't understand what happened.
For over 30 years, Texas Instruments had dominated the semiconductor industry by mastering the production of commodity chips, basic to everything from garage door openers to simple computers. But by the mid-80s, TI's customers were designing new, sophisticated products that were not assembled from commodity chips. Cellular phones and laptop computers demanded customized chips, special chips for each different product.
The customized portion of the semiconductor market was becoming the fastest growing part of the market. So a huge increase was going to be required of these products. And so the area that we had to be excellent in was the same area where our customers were telling us that we were terrible.
With the competition intense, new products often become obsolete in months, and the customized chips that power them had to be delivered fast. But Texas Instruments was not up to the challenge with delivery. We would have long cycle times, long delivery times, poor on-time delivery. So customers could get the chip designed by TI, but when it came time to actually ship product, there would be no chip there.
Personally, I spent 50% of my time answering customer complaints on why we're not able to do what some of our competitors were doing. We had two of our largest customers come in and tell us, unless you made some significant changes, we aren't going to do business with you on these custom products in the future.
By the spring of 1991, the situation at Texas Instruments had grown desperate. Top management appointed a re-engineering team to study its semiconductor division with special attention to how custom orders were being filled.
Now, we knew order fulfillment was a big problem because our customers were telling us that. And the customer's telling us that he's going to quit doing business with us because we're so bad, this is a good clue that we might need to re-engineer.
When Texas Instruments only made commodity products, order fulfillment was simple. TI's warehouses were stocked with millions of chips. When a customer placed an order, the chips were immediately shipped from inventory. But in the new competitive world of custom products, the goal is to have no inventory. Now, when a customer with a product places an order, chips are manufactured for that product alone. But TI wasn't up to the challenge of customized service. The division had come to rely on a disorganized expediting system. The
Before we re-engineered, we would have expedites, we would have hot expedites, we would have upper dollar sign expedites, we would have hot expedites. It actually got to the point where we didn't know what a double dollar sign meant versus a hot, and which one would have higher priority.
And over a period of time, as the customer became more dissatisfied, everything became a hot lot, and it kept skewing up to eventually where everything was going to be a super hot lot, and if it wasn't, it would never come out of the factory.
To further complicate matters, Texas Instruments' manufacturing process begins on one continent and ends on another. Production starts in Dallas, where hundreds of chips are etched onto silicon wafers in factories called wafer fabs. From Dallas, the wafers are then flown to one of several assembly plants in the Far East, where scores of workers slice each wafer into hundreds of separate chips and then marry each chip to its own electronic housing. A large portion of the chips are returned to Dallas, where they are shipped to customers.
So by the time we actually built one of these products, it may have traveled 30,000 miles on an airplane. Well, while that might be good for extremely high volume products, it has terrible cycle time for those types of products that need to be rushed through.
There were even more delays, because each factory operated as an independent kingdom, often in direct competition with all the rest.
In fact, a lot of comparisons were done between factories. So the incentive is to make yourself look better than the other people.
With competing factories thousands of miles apart, all using an inefficient expediting system, Texas Instruments was taking 180 days to fill a custom order, more than 6 times as long as its best competitor. The re-engineering team approached management with a radical proposal.
The vision we proposed to management, the most controversial or eye-opening piece was we said we can no longer afford to have factories scattered around the world. We need all the pieces of our factories integrated together under one roof.
We didn't need separate wafer fabs and assembly test sites, but we should put them all in one building and remove the in-transit in between our factories.
It sounded real good, but it also probably created the biggest stumbling block in our re-engineering effort on moving forward. Because it really said that when you look at the process re-engineering, it's true you need to wipe the slate clean and start all over. But there's some things, the rotation of the earth, the fact that the sun comes up and down, and the fact that we've got 3,000 employees here for 25 years and all the expertise to do that, we can't just pick up a mountain and carry it across the ocean and set it down again. Not in a reasonable amount of time.
We now have managers coming back to us and saying, look, yeah, you did a real nice exercise, but if you don't figure out how to make this happen, we're going to disband you.
The team had presented an ideal solution, but would now have to face reality.
We have factories all over the world, and we can't change overnight. What do we do with the existing factories that we have? How do we make improvement using these facilities?
They went back to the drawing board and began to brainstorm. Anything was possible.
At the time we were talking about this, the term virtual reality was something that everybody was kicking around, and so we started saying, well, we just need to pretend we're one factory. We just need to be beamed up between factories.
And somebody within the team basically came across and said, what if we have a virtual factory?
A sudden leap of imagination spun the re-engineering team in a new direction. What if Texas Instruments treated each of its American wafer fabs as if it were linked to an Asian assembly plant under an imaginary roof stretching for thousands of miles? The real buildings would stay where they were, but new strategies would be put in place so that their managers and workers, separated by an ocean, would act as if they were together in one factory.
And we call that the virtual factory. Instead of operating independently, they now operate together as part of the same process flow.
And letting those factories work together to solve the handoffs and interfaces between them and measure them as a common process and not an individual entity, that allowed us to really start putting some hard actions into place that began to show progress.
Texas Instruments began building its virtual factory by bringing order to the start of order fulfillment. The re-engineering team created a computer program designed to replace hundreds of expedites and guarantee customers a firm start and end date for their orders.
using the software has reduced a lot of the uncertainty. Let's say the customer needed a start on Monday. In the old systems, there was no guarantee that the material would start on Monday. It simply took that requirement, combined it with everything for the week, and perhaps it would start that customer's order on Sunday. With the current systems, we know exactly what day of the week that order needs to start on.
But making a virtual factory would take more than creating a new piece of software. After decades of acting independently, the managers of the wafer fabs and the assembly plants will have to learn to cooperate.
Now, in the past, those sites never talked to each other. Each was looking at improving its own operation, improving its own products. When we put those together as one flow, now the managers of each of those facilities were being measured on the results of the total process.
We changed the reward system to where no longer, if a factory did well in its block of work, were they rewarded. Only if the whole entire process did well were any pieces of the process rewarded.
About 25% of a manager's pay would be at risk as part of this process. So it became a great incentive to work together, and it was team-based. So either all managers made it or no one got it.
Along with a new system for motivating managers, TI needed to retrain tens of thousands of workers in dozens of countries. They hit on an ingenious plan. They called it the Jonah Net.
One day, I was just working and my manager came by and said that they had decided I was going to be a Jonah. And I said, well, what's a Jonah? And I don't have time to be a Jonah. I've got too much work to do. And he assured me that it was going to be a good program for TI.
Instead of retraining all its workers at once, Texas Instruments selected just 150 from among the most respected people in its factories throughout the world. TI called this special group Jonahs. All were brought to Dallas for a month of intense training.
We sent them to extensive training to learn really the fundamentals of variability reduction, cycle time management, inventory reduction, and all of the really fundamental changes that we needed to incorporate if we were going to make improvements in the total order fulfillment process. We then let these Jonahs go back into their factories and fan out what they had learned.
OpenCVD, how O54 is down for a cube change.
By sharing their training, the Jonah in each factory has helped teach other workers new and innovative methods for cutting time out of the production of custom chips.
One of the things is to analyze where your bottlenecks are. And you'll always have bottlenecks, but you need to learn how to manage your bottlenecks. And this is some of the training that we learned in our Jonah classes.
Before Jonahs, an innovation in one factory rarely spread beyond that factory's walls. Now, through an email network linking all 150 Jonahs, new ideas can be shared by every wafer fab and assembly plant.
And by having this network of Jonahs throughout the world, we had a community of people who were all being trained the same way, knew each other so they could share improvements, and this community became very strong, leading to change.
It was important for the culture at TI to change. We had been working for years as independent components, so to speak, the wafer fabs separate from the assembly sites, etc. Now we're being scored as one team, all the way through the assembly site. So when a customer makes an order to when the customer gets the product is what we're counting.
Today at Texas Instruments, the virtual factory has become a reality. After just 1 year, the semiconductor division has cut more than 50% of the time it takes to fill its custom orders.
Number one result in our re-engineering effort is that we went from worst to first in customer satisfaction and customer service. We're now recognized throughout the industry in a time when demand has exceeded supply for 2 straight years. We're serving our customers better than any other competitor that we have.
This is an example of a company whose markets have dramatically changed. And now Texas Instruments must rethink the way it does its work and become more nimble. Now, re-engineering doesn't necessarily mean restructuring or centralization or consolidation. You may want to protect valuable people assets and valuable capital assets. Here, Texas Instruments chooses a virtual organization. But as managers, we must pay attention to at least 4 sets of issues if we wish to have such a virtual organization. First, the issue of culture. Remember, under the old order of fragmentation, people actually often competed, that they had an inward focus, that they measured activity rather than result. We must change that focus. So we're now competing only with other companies, and we actually do operate as a single company, as a team. Secondly, in order to drive that behavior, we must pay attention to our reward and recognition systems, how we pay and compensate, to align those recognition systems with the new behavior. Thirdly, information technology becomes a critical enabler, both as something that allows us to operate in a dispersed way, but also as something that allows the sharing of knowledge. And finally, as managers, we must be very disciplined about implementation. It's one thing to think about a smart design, a concept on paper, another thing to implement it with 10,000 employees. Here we see an example of a core group of people who have been re-educated, who now move forward broadly into the organization to help and stimulate the re-education and refocusing of the whole enterprise.
聽啲乜嘢？唔係我話 re-engineer 係因為佢個嘥機。